How does this form of power produce energy? Geothermal power is generated using steam. It's really a lot simpler than you think. To set the system up, you locate an underground area with heat and water and drill 2 holes down to it. You then install metal pipes in both. You collect the steam from the underground area into a pipe and funnel it towards a turbine. The steam then pushes the blades on the turbine, causing the blades to turn. When the turbine turns, it turns a shaft, called a rotor, which is connected to a generator. As the rotor turns, the coiled copper wires are being passed through a ring of magnets. When the wires are moved through the magnets move the electrons in the wire, generating an electrical current in the copper wires. We then transfer the electricity out of the power plant and to consumers. After the steam turns the turbine's blades, it continues moving through the pipe, making its way to an area called the cooling tower. In the cooling tower, the steam is given time to cool down. Once the steam is cool, it is pushed back down into the underground area that it was taken from. This allows it to heat up again and be reused. How much is it used in society today? Is demand increasing or decreasing? Well, according to the U.S. Energy Information Administration, only about 7 states are using geothermal power. Utah is currently the third biggest state in terms of geothermal power generation, right behind Nevada and California. So given the populations of Oregon, Idaho, Nevada, Utah, California, New Mexico, and Hawaii, the 7 states listed, it's about 55.427 million people, and demand is only increasing as time goes on. What are the benefits to using this form of energy? Geothermal power is a clean, renewable source of energy. Geothermal power produces no greenhouse gases and has lower life cycle emissions than both solar and natural gas power. Geothermal power's life cycle emissions are 4 times lower than solar's and 6 to 20 times lower than natural gases. Does it have environmental restrictions, like locations or weather conditions? Yes and no. It does require that you be as close as possible to a geothermal hotspot, but the power plant itself can run regardless of the weather, and it is minimally environmentally damaging. The Yellowstone supervolcano alone has enough geothermal energy to power the world more than 300 times. Wind and solar power aren't reliable enough due to their dependency on the weather. Geothermal power doesn't have the same restrictions. Nuclear power is actually too efficient. It generates way too much energy for low power needs, but can usually keep up with higher power ones. If we generate too much energy, it overloads our power grids. This causes a lot of problems, like major power outages and overloaded circuits. What are the cost drawbacks? The average is, according to the U.S. Department of Energy, 2,307 milliwatts square per hour, but considering how energetic Yellowstone is, it would be vastly higher. It could range anywhere from $18,000 to $30,000 to build, but it would only take $2,500 to maintain per active kilowatt hour. So we have a plan. Since people don't like their property near power plants, we have chosen a more secluded geothermal hotspot. We simply build a plant in Idaho just outside the Yellowstone border, then drill the holes diagonally to access the geothermal power from outside Yellowstone. But you may ask, how will we get it to Utah? The answer is simple and high-tech: superconductor lines surrounded by liquid nitrogen. And that's how Utah would power all its grids, and if we truly tap Yellowstone's potential, the whole world. This would be a great solution to our power problem, because of how much power Yellowstone would generate if we used its geothermal potential, and how controllable the output of power from a geothermal power plant is, combined with how safe it tends to be, and some of the new designs, with the goal of minimizing a power plant's environmental effect. And considering how close Idaho is, the energy wouldn't have to travel far, and if we used superconducting wires, then we get an almost zero energy loss in transfer. Geothermal power plants are some of the cheapest power plants to run, for how much energy they produce, and even though people do not tend to like living near a power plant, Geothermal power plants would be some of the only sources of power that an individual could live next to.